In this problem, we're asked to use Descartes' rule of signs to find the number of roots possible for this polynomial equation x to the fifth plus x to the third plus 5x equals 0. Okay, the first thing we should do is check the degree of the polynomial. The highest power on x is the fifth power, so there are 5 complex roots that we're looking for. Next, we're going to see the number of positive real roots. We do that by checking the number of sign variations in f of x, where f of x is the function that's equal to 0. It's x to the fifth plus x to the third plus 5x. Well, it never changes signs. All those terms stay positive. So there are 0 sign variations in f of x, and that implies there are 0 positive real roots. I mean, if it were a different number, we would subtract even numbers 0, 2, 4, 6, 8 to come up with different possibilities. But this is simple. There are no positive real roots. Now we'll check the number of negative real roots. We do that by looking at the number of sign variations in f of negative x. Remember how we find f of negative x? We go to f of x and change the sign in front of every term that has an odd power. All of those powers are odd, 5, 3, 1, so change the signs in front of every term. Then count the number of sign variations. 0 sign variations in f of negative x. It never changes signs. So again, here we have that there are 0 negative real roots. Oh my gosh, there are going to be 5 complex roots, and none of them, well, we found no positive real roots. We found no negative real roots. Are there any possible values of roots that are neither positive nor negative? Well, yeah, there is. There's that weird number 0. The number x equals 0 is actually considered always positive and negative, or another way of looking at it, it's neither positive nor negative. So let's see if this number that's neither positive nor negative is indeed a root. Is x equals 0 a root? Well, to be a root means when you plug this value in for x, it makes both sides of the equation the same. We've got 0 to the fifth plus 0 to the third plus 5 times 0. Is that equal to the other side, 0? Yes, 0 equals 0. So the answer is yes. X equals 0 is a root. So we're going to have an extended table. It's not going to be just like we did in class where we had positive real roots, then we added negative real roots. Now we're going to add the possibility of x equals 0 itself as a root, which would be one more root that was real. And then we're going to add the number of not complex but imaginary roots, and that should total the entire 5 complex roots. Now, there are going to be 0 positive real roots. We know the total will be 5, but 0 positive real plus 0 negative, and we found that x equals 0 is a root, so there's one root there, and then whatever is left has to add together to 1 to give us 5. So the answer is there will be 5 imaginary roots, and that's the complete table. So that x equals 0 was the booger that was bothering us because it's not considered positive or negative, it's just 0. So x equals 0 is one additional root that we have for this particular problem.